Standard deviation. The most commonly used measure of variability is the standard deviation, which is denoted by S, or the Greek letter small sigma, which looks like a circle with a little tick off the top. The standard deviation gives the average deviation or difference of each result from the mean. Thus, the more widely spread out the data is, the larger the standard deviation will be. So this is the formula for standard deviation. Let x bar be the mean of the data x1, x2 up as far as xn. Then the standard deviation, or sigma, is given by sigma equal to the square root of x1 minus the mean squared plus x2 minus the mean squared plus ... up as far as xn minus the mean squared. And this is all divided by n. Example: A, 9, 10, 11 and B, 5, 10, 15 are two data sets, each having a mean of 10. 9 plus 10 plus 11 is 30 and divided by 3 is 10. And 5 plus 10 plus 15 is 30, divided by 3 again is 10. So they've got the same mean, they both have a mean of 10. Part 1. In your estimation, which data set has the greater standard deviation? And give a reason. The elements of B are more widely spread about the mean than are the elements of A. Thus, we would expect B to have the greater standard deviation. So we can see 9, 10 and 11 are all very close together. They're all very close to the mean of 10. But 5 is quite far from the mean and 15 is also quite far from the mean. So we expect B to have the greater standard deviation. Part 2. Find the standard deviation of A and the standard deviation of B, correct to 2 decimal places. Comment on the two values. So we're going to use our formula, which is sigma is equal to the square root of the sum of x minus the mean squared, all divided by n, the number of values. So for A, we have 9 minus 10 squared plus 10 minus 10 squared plus 11 minus 10 squared. And that's all divided by 3 because there's 3 values in the data set. 9 minus 10 is minus 1 squared is 1. 10 minus 10 is 0, 0 squared is 0. 11 minus 10 is 1, 1 squared is 1. 1 plus 0 plus 1 is 2. So we get root 2 over 3, which is 0.82. And then for B, we use the same formula. So we have 5 minus 10 squared plus 10 minus 10 squared plus 15 minus 10 squared. Again, that's all over 3. So 5 minus 10 is minus 5. Minus 5 squared is 25. 10 minus 10 is 0. 0 squared is 0. 15 minus 10 is 5. 5 squared is 25. And that's all over 3. And we have the square root. 25 plus 0 plus 25 is 50. So that's root 50 over 3, which is 4.08. As expected, the standard deviation of B is greater than the standard deviation of A. 4.08 is greater than 0.82. The lengths in centimetres of a number of fish which were captured and tagged in a lake are recorded in the table below. So this row represents the length in centimetres and this row represents the number of fish. So for example, there was 4 fish measuring between 0 and 10 centimetres. Part 1, calculate the mean length of the fish. We will set up a table to calculate both the mean and the standard deviation. So our first column is going to be our intervals that we got from here. Our next column will be the midpoint, or the mid-interval values. So halfway between 0 and 10 is 5, halfway between 10 and 20 is 15, and so on. Another way to do this is to add these two values together. So 10 plus 20 is 30, and divide by 2. 30 divided by 2 is 15. So we have our midpoints, or our mid-interval values. Our next column is our frequency. So 4, 16, 20, 12, 6. Our next column is xf. So we're going to multiply our x values by our f values, our frequency. 5 multiplied by 4 is 20. 15 multiplied by 16 is 240. 25 multiplied by 20 is 500, and so on. So now we have our xf column. We need to add up our frequencies, 58, and add up our xf column, 1450, and divide the sum of x times f by the sum of f, which is 1450 divided by 58, which is 25 centimeters. So x bar, or the mean, is 25 centimeters. So we got this formula from page 33. Next, we need to work out the standard deviation. So we're going to continue with our table to find the standard deviation. So our next column is x minus x bar. So our x values is this column here, and we have to subtract the mean, which we worked out to be 25. So 5 minus 25 is going to be minus 20. 15 minus 25 is going to be minus 10. 25 minus 25 is going to be 0. 35 minus 25 is going to be 10. And 45 minus 25 is going to be 20. Next, we need to square our x minus x bar values. Minus 20 squared is 400. Minus 10 squared is 100. 0 squared is 0. 10 squared is 100. 20 squared is 400. So now we have our x minus x bar squared column. And next, and finally, what we have to do is multiply our x minus x bar squared column by f, the frequency. So remember, this column here is the frequency. So it's going to be 4 multiplied by 400, and 4 times 400 is 1600. Then 16 multiplied by 100, 100 times 16 is 1600. 20 times 0, 20 times 0 is 0. 12 times 100, 100 times 12 is 1200. 6 times 400, 400 times 6 is 2400. And then we're going to add these up, and we end up with 6800. So for the standard deviation, it's going to be 6800, which is going to be our numerator, divided by 58, which was the sum of our frequencies. And we need to square root that. We get 10.83 centimeters. So we can also follow this formula, which is the same thing. So we apply the square root at the very end, and then we add the x minus mean squared value times the frequency, and we divide by the sum of the frequencies.